Let's add a new node for our player as a direct child of our world node. For the node's type, we're going to use the character body 2D. A character body is a special type of physics node made specifically for characters that we wish to control with code. Rename the node to player. Before continuing, we're going to convert our player into a scene, just as we did for the platform. Right-click on the player node and choose Save Branch as Scene. Navigate to the Scenes folder and save our player scene here as player.tscn. With that done, click on the movie clip icon next to our player in the Scene panel to begin editing our player scene in isolation. You'll see the familiar yellow warning triangle asking us to create a collision shape. Just as we did with the platform, we'll first add our player sprite so we know how big to make our collision shape. However, instead of using a Sprite 2D node, this time we're going to add an animated Sprite 2D. Once again, create a child node and search for it by typing Sprite, and making sure to choose Animated Sprite 2D from the list. You should hopefully be getting quite comfortable with this process by now. The Animated Sprite 2D differs from a standard Sprite 2D in that we can define various animation states that are composed of multiple frames rather than a single static image. The yellow warning triangle here is telling us that we need to define those frames, so let's do that now. In the inspector, click the drop-down next to the Frames property and choose New SpriteFrames. Once done, click on the now populated SpriteFrames resource. You should notice that now we have a new panel appear at the bottom of our editor. This is the SpriteFrames panel, and it allows us to define animations for our animated sprite. By default, it's created a single animation, somewhat aptly named Default. Let's rename it to something more appropriate for our game, and call it Run, since our player will immediately start the game in a running state. Next, we need to tell it which images to use for this animation. To do this, we can click on the small grid-looking icon just underneath where it says Animation Frames. This button allows us to add frames from a sprite sheet and will open a file dialog asking us to locate the relevant sprite sheet. Navigate to the Assets, Sprites, Player folder, and choose the player run.png file. You'll now see a new window appear which shows the sprite sheet in its entirety. Here, we need to tell Godot the configuration of our sprite sheet in terms of how many frames there are both horizontally and vertically. You can see that by default it's trying to split the sprite sheet in a 4x4 grid. At the top left, change horizontal to 8 and vertical to 1. You should now see that it's splitting our sprite sheet appropriately. The last thing to do is select which frames we want as part of our run animation. Since we have separate sprite sheets for each animation, we'll select all of them by clicking and dragging across them all and pressing the Add 8 Frames button. We can now see our player in our viewport. However, you'll notice that right now it isn't animated. Let's fix this by ticking the Playing property in the inspector. We can now see the player sprite animated. Let's make one small tweak to make it feel a bit smoother. At the bottom left of the SpriteFrames panel, change the speed value to 12 FPS. Much better. While we're here, let's add the other animation states to our player. Click on the icon with the page and plus symbol above where we defined our run animation. Rename this new animation to Shoot. Click the Add Frames from Sprite Sheet button, and this time choose the player run shoot.png sprite sheet. Again, we'll set 8 for horizontal and 1 for vertical. Select all of the frames and click Add 8 Frames. Make sure to change the speed to 12 FPS. Once again, create a new animation and call it Jump. Click the Add Frames button again and choose the player jump.png sprite sheet. Set 8 for horizontal and 1 for vertical. Select all of the frames and choose Add 8 Frames. Again, set the speed to 12 FPS. Let's add one for letting the player double jump. We'll call it Double Jump. And choose the player double jump sprite sheet. This time, we'll set 7 for horizontal and 1 for vertical. Remember to change the speed to 12 FPS. Just one more, and that's the death animation. Call it Death, and choose the player death sprite sheet. This one's a bit longer, 9 on the horizontal and 1 on the vertical. Once again, remember to set that speed to 12 FPS. With all of those animations added, you might have noticed that our player appears to be dying over and over again in our viewport. Let's fix that by unchecking the loop option at the bottom left of the SpriteFrames panel for our death animation. We also want to do this for the shoot animation. The last thing to do for animations is change the default animation state back to run over in the inspector. With our animations configured, let's add an appropriate collision shape to our player. Add a collision shape 2D as a child of our player node, and create a new rectangle shape 2D resource for the shape property in the inspector. Click on the rectangle shape resource and change the size to 100 on the X and 200 on the Y. As well as changing the size, let's tweak the position to more accurately fit our player. Under the transform section, set the position Y to 15. This will move the collision shape slightly down to the player's feet. You may be wondering why we're not covering the entirety of our player's sprite with the collision shape, and the answer is twofold. One reason is that the smaller collision shape will make it easier for our player to comfortably move between platforms without colliding with them in awkward ways. Another reason is that we want to be forgiving to our player when it comes to them colliding with enemies. Having a smaller collision shape, also known as a hitbox, gives our player a bit more of a fighting chance to avoid dying and ending their run prematurely. Speaking of collisions, let's configure our player node to live in the player physics layer that we defined earlier. We'll do that by selecting the player node, and over in the inspector expanding the collision section. Under the layer property, click on the box with the number 1 on it to remove our player from the environment layer, and now click on the number 2 box to add our player to the player physics layer. Remember, you can always hover over the layer boxes to see the name of them. We'll leave the mask property as is. With our animations in collision shape done, let's go back to the main scene. You may notice that our player looks a bit too big when compared to our platform. Let's fix this by selecting the player scene in the hierarchy, expanding the transform section and changing the scale to 0.4 for both the X and Y values, and changing the position to -150 on both the X and Y axis. It's worth noting that instances of scenes can override their default property values. By making the change to the player's scale and position here in the main scene, rather than inside the player scene directly, we're only modifying the values of this particular instance of the player. To demonstrate what I mean here, let's come down to the file system panel and find our player.tscn scene file inside the scenes folder. Click and drag this file into the viewport to create a brand new instance of the player scene inside our main scene. You'll notice that this new instance retains its original scale value. Before moving on, let's delete the player 2 instance from our scene. Okay, it's time to dip our toes into Godot's scripting language, GDScript, and start bringing our player to life. Start by going into the player scene, either by selecting it from the tab at the top if it's open, or by clicking the movie clip icon in the scene panel in the main scene. To add a script to our player, right-click the player root node and choose Attach Script. This will open the Attach Node Script dialog. Here, we can choose the language for the script, which we'll leave as GDScript. We can select which node type this script will inherit from. Again, we'll leave this as the default value, which is character body 2D since this is the type of node that our player is. The next option allows us to choose a pre-made template. The default for a character body 2D is a basic movement script. However, for our purposes this won't be useful, so instead we'll untick the template option and start with a blank script. Lastly, we can specify a path and a name for our script. There are many different ways to organize various assets and scripts within your game, but for simplicity's sake, we're organizing ours by type. So let's create a scripts folder and save this script as player.gd. Next, click Create. We've now been taken to the script view, and our player script is open. We'll cover the basics of GDScript throughout this course as we go, but it's worth taking some time reviewing the fundamentals on the official Godot documentation site. You'll find a link to that in the description below. Let's start by defining a function that will run as soon as our player node is ready. We can do this by using the func keyword and giving the name _ready. We'll also add an empty pair of parentheses followed by a colon. For anyone familiar with Python, this should look extremely familiar, as GDScript is heavily influenced by Python's syntax and structure. On the next line we'll type print, open bracket, quotation mark, hello world, close quotation mark, close bracket. Note that this line was automatically indented by the editor. This is important as it tells Godot that this line belongs to the ready function we just defined. Speaking of the ready function, this is a special function that Godot will automatically call as soon as the node it belongs to has entered the scene tree and all of its child nodes are also ready. This means that we can use this function to perform any initial setup for our node. For now, we're simply going to output the words hello world to the output window to verify that it's working. Save the script by going to the File menu and choosing Save, or using the shortcut Ctrl and S if you're on Windows. Now press the play button at the top right to once again start our game. We can see that the words hello world have indeed been printed out to the output panel. Now that our script is correctly attached to our player and working, let's add some gravity to our player so that they fall and land on the platform below. Let's begin by defining a variable for the strength of gravity that applies to our player. We'll also want to be able to modify this value from the node inspector, so we'll define it with the @export keyword, and give this variable an initial value of 1600. The export keyword exposes the variable to the inspector where it can be edited at design time. If we quickly jump over to the inspector, we can now see that our gravity variable is displayed and we can make adjustments directly in the editor. With the strength of gravity defined, we need to apply it to the player. We'll do this inside another special Godot function, the _physics_process function. This function gets called at a set interval determined by the physics ticks per second setting in the project settings. By default, it runs at 60 times a second. It takes one argument called delta, which is the time taken in seconds between the last physics frame and this one. We can use this to make sure that any physics motions we apply to our player is consistent regardless of frame rate. We're going to update our player's Y position by the value of our gravity value multiplied by the delta value. This will apply a set amount of gravity to the player each frame. We then need to call a function of the character controller 2D called move and slide. This will use the current value of the velocity variable to move the player accordingly. Let's save the script and hit the run button. We can see that our player now falls and lands on the platform. Great, this means our gravity is working. Okay, now that our player can fall, let's give them the ability to jump. But to do this, we're going to need to add some input controls first. Let's go to the Project Settings window and click on the Input Map tab. This is where we can define the controls for our game. Click where it says Add New Action, and let's give it a name of Jump, all in lowercase. Now click the Add button. In the list of actions below, we can now see our jump action. Click on the plus symbol to the right. This opens a panel that allows us to define what input key or button to use for this action. Press the space key on your keyboard and you'll see that it identifies the key. If it doesn't, you can also go to the Manual Selection tab and choose the space key by searching for the word space in the Filter Inputs box. Once you've selected the space key, click on OK. While we're here, let's also define an input for our fire key. Again, type the name of the action where it says Add New Action, we'll type fire in lowercase, and then hit Add. Click the plus symbol, and this time we'll use the left control key. Feel free to use any other key that suits here. We'll be referring to the action by its name in the code, so the actual input key doesn't matter. Once you've chosen the key you want, click OK. We can now close the Project Settings panel. Just like we did for gravity, we'll define a variable for the strength of the player's jump. We'll export this too so that we can tweak it in the inspector, and give it an initial value of 600. We're going to want to play the player's jumping animations when they jump as well, so for this we'll need to get a reference to the animated sprite 2D node inside the player. We can do this by using the @onReady keyword and the $syntax to specify the path to the node that we want. The onReady keyword defers initialization of the variable until that node's ready call has been made. This ensures that when we access the variable, the node has already been initialized and we can access it without any issues. To get our animated sprite 2D node, we'll write the following. Here we use the $sign followed by the name of the node we want to reference. The $sign is a bit of a syntactic sugar for the getNode function, and you'll often see it used instead of the long form of calling get_node explicitly. Since the animated sprite 2D is a direct child of our player, we can just specify the name directly. It's worth noting that you can also use the $sign followed by a set of double quotes, and instead provide a relative or absolute path to the node that you want to reference to. We'll use this alternative method later to get access to other nodes in our scene. We only want our player to be able to jump if they're still alive. So for this, we're going to keep track of whether the player is active or not by defining a variable called active. We don't want to be able to change this in the inspector, so we won't bother with the export keyword. We'll set its initial value to true. It's a good idea to visually separate variables that are exported versus ones that aren't, so we'll make sure to leave a gap between our exported variables and this one. We also want to add a couple more variables to control the logical flow of when our player can jump. Let's add a jumps remaining variable with an initial value of 2, and a was jumping variable with an initial value of false. In our physics process function, right after we apply gravity to our player's Y position, we'll do a check to see if the player is still active by using an if statement. We can say if active, which means if the variable active has a value of true, and end the statement with a colon. On the next line, let's add a comment to say that we're going to handle jumping. You can add a comment by prefixing the line with a hash symbol. Note that you should see your comment as indented below the if statement. Below our comment, let's check to see if the player has just pressed the jump key, and if they have any jumps remaining. We can get the status of the input action by calling the input.isActionJustPressed function, and passing in the name of our action, which is jump. We also want to check that our jumps remaining variable is greater than 0. We can do this by using the AND keyword. If the action was just pressed, we'll decrease the jumps remaining variable and set the was jumping variable to true. We'll also set the player's velocity.y value to negative jump power. We use negative here because up in Godot is negative on the y-axis. Now, we want to change the player's animation from the running animation to either the jump or double jump animation, depending on how many jumps the player has left. If the player has just one remaining, then play the jump animation. Otherwise, we play the double jump animation. We use a double equals sign here to check for equality. To play the appropriate animation, we call sprite.play, and give it the name of the animation state that we want to play. If you run the game now, you'll see that our player falls to the platform, and hitting the spacebar key makes the player jump. But there's a problem. The player can jump a maximum of 2 times, and then no more. We need to reset the player's jumps remaining counter whenever they hit the ground. Above our handle jumping comment, let's add a new one that says, reset the player after landing. Here, we'll check to see if the player was just jumping, and if they're currently on the floor, using the special isOnFloor function. If both of these things are true, we'll set wasJumping to false, reset the jumps remaining variable to 2, and then play the player's run animation. If we play the game now, you'll see that we can jump or double jump, and then after landing, we can jump or double jump again, and all animations play as expected. This is great, but there's one last piece of the puzzle for jumping, and that's to add sound. In the scene panel, let's add a new node to our player. We'll add an audio stream player node and call it jump sound. Let's drag a sound from our file system panel into this audio stream player's inspector under the stream property. We'll choose the jump sound from the Assets Sound folder. With the sound node added, let's get a reference to it in our player's script and call it jump_sound. We'll also add a new variable called jump pitch that will control the pitch of our jump sound. We do this so that when the player double jumps, we can use the same jump sound but slightly increase the pitch to make it feel a bit different. We'll give it an initial value of 1, which is the default pitch value of a sound. Where we're resetting the player's jumps remaining variable, let's also reset the jump pitch value to 1. Moving down to after we play the appropriate jump animation, we'll first set the pitch scale of our jump sound using the setPitchScale function, and passing it the current value of our jump pitch variable. We'll then play the sound using the play function, and finally, we'll increase the value of jump pitch by 0.2. This will increase the pitch for when the player double jumps. Let's give it a test. Try jumping and double jumping, and notice how the sound changes as the player performs a double jump. After landing and jumping again, you should notice the sound resets as we expect. Awesome! Before moving on, click on the player's root node and notice in the inspector that we can see the values of our player's gravity and jump power. We can change these values and they'll impact the strength and gravity of how high the player can jump. Feel free to play around with these values and test them out by running the game. For example, what happens if you set the value of jump power to 100? Once you've had a play, reset them back to 1600 for gravity and 600 for jump power for now. Let's take a brief pause to quickly talk about source control. If you're unfamiliar with the concept, source control allows us to effectively snapshot our project at a particular point in time. We can then continue working on the project, adding new features or fixing bugs, without the fear of breaking or losing something we've already done. At any point, changes to our project can be rolled back or amended, kind of like a time machine for code. If you're familiar with source control, now would be a good time to commit the work that you've done. If you're unfamiliar, I highly recommend learning the Git source control system. You can find more information about Git at git-scm.com. You may have noticed when jumping that the camera stays still and our player almost goes off the screen. We don't want this to happen. Instead, we want our camera to follow our player smoothly. Let's grab a reference to our camera node inside our player script. We can do this by using the $syntax and specifying the absolute path to our game's camera node. Since it lives inside our main scene under the world node, we'll start from the root of the scene by using the path /root/world/camera2d. Inside our physics process function, just below our active check, we'll set the camera's position to our player's current position. Let's test the game again and see that our camera now smoothly follows the player as they jump. Awesome!